All right. Today we're going to do 4.4, which is graphing quadratic inequalities and also graphing systems of linear quadratic and quadratic quadratic. So lots of graphing. With inequalities, notice that this has an inequality symbol. Okay. Just some stuff. If it has a greater than or equal to or less than or equal to, we're going to use a solid curve. Just like we used a solid line when we did inequalities, linear inequalities. And if it has greater than or less than, we're going to use a dashed curve when we connect the parabola. Just like when we did linear inequalities, if it's greater than, we're going to shade above. And what you're going to look for is above the vertex. And if it's less than, we're going to shade below. And again, you're going to look for below the vertex. Now, we need to know how to graph these. Okay? So this one's obviously easy. That one we could do transformations. Didn't that move right 3, down 2, and then we stretched it by 3? Or you could pick out the vertex is at 3, -2. So let's go ahead and graph 3, -2. Okay? We could find the y-intercept, or we could just use this pattern, over 1, up 3. Usually we do 2, 4, so we're going to be doing 2, 12, and that would put us up here. Alright, so we have the ordered pairs. I just graphed it by going right 3 and down 2, and that's also what the vertex is, and then I did the pattern is 3. So instead of doing 1, 1, I did 1, 3. Instead of doing 2, 4, I did 2, 12. Okay? Now, based on this inequality symbol, it has an equal to, so that means that we use a solid curve. So go ahead and connect it with a solid curve. If it didn't have that equal to, we wouldn't be using a solid curve. And now look at that symbol. It says less than. So less than, you want to shade below the vertex. So here's the vertex, and just point to where less than. It's right here. That shows you that you shade everywhere on that side of the parabola. It's either going to be inside or outside the parabola. And if I needed a solution, you would just give me any ordered pair in the shaded area. Okay, so that one was easy to graph. Now this one I can't do transformations. So what you're going to do is you're going to find the axis. This is in standard form, so you find the axis of symmetry. Remember, this is your formula. So our b value is -2 and our a value is 1. So what we get is 8 over 2, so x equals 4. So go ahead and put your dashed line at 4. That's going to help us graph it. And that's a little bit off. Now, let's find the vertex. We know the x value is 4. Go ahead and plug in what's 4 squared minus 8 times 4 plus 20. So that's going to give you 16 minus 32 plus 20. So that's going to be -16 plus 20, which is going to give you 4. So 4, 4 is where your vertex is. Okay? We also know it's going up. If we found the y-intercept, it would be 20, so we can't really fit that. But this out here is just a 1, so our pattern is just a regular 1. So go ahead and do 1, 1, and 2, 4. And now this one, you're going to want to connect with a solid line as well. And now this one says greater than. So what you're going to do is you're going to go to the vertex. You're going to plot greater than. So greater than is right here, okay, just above. So that shows you that you're going to be inside the parabola. And again, if I wanted a solution, you would give me any ordered pair in that area. Okay? All right, the next thing that we're going to do is when we're going to have systems of inequalities. Oops, sorry. So we could either have a system of quadratic-quadratic, so 2 quadratics together, or we could have a system of linear quadratic, okay? So something like this. This would be a linear quadratic. So to graph this, can we do transformations here? Yes, because that's down 5, and that's a vertical stretch by 2. So we can graph that. Just move your parabola 1, 2, 3, 4, 5, and go ahead and do a pattern of 2. Over 1, up 2, over 2, up 8. And I don't think we can fit anything else. And now these aren't inequalities, so we just graph the regular parabolas. And remember, you always need as many points as you can. This is really bad. Hold on. Let's try again. Okay. That's as good as it's going to get. 60 here. Okay. Remember with a system, what you're looking for when you graph a system is the points of intersection. It could have one point of intersection, it could have two, it could have 0. All right, now this is a linear function. This is your y-intercept, so go down to -1 and put a point. And this is your slope, so go up 2 over 1 and make as many points as you can. And what we're looking for, remember, is points of intersection. And we connect this. And where do the red and the blue intersect? How many times? Twice. One right here and one right here. And you need to write down the points of intersection. The point of doing this is to find where they intersect. So we're going to go over 1 and down 1, 2, 3. So 1, -3. And we go over to -2 and we go up 1, 2, 3. So -2, 3. Those are your 2 points of intersection. Okay, so if I give you a linear quadratic system, one should be a line, one should be a parabola. If you can graph the parabola by transformations, that's the easiest way. If you can't, that's when we have to find the properties like I did in the last example. And then once you graph them, you're going to figure out the point or points of intersection. All right, over here, it looks like we can do transformations. This one moved right 1 and down 2. So go ahead and let's do a parabola that has been moved right 1 and down 2. And it's the regular pattern. So 1, 1, 2, 4, 3, 9. And I don't think we can fit 4, 16. So there's your parabola. Your first one, I should say. That's not good, but. All right, now the next one is also a quadratic. It's been reflected over the x, so it's been flipped upside down, and it's been moved right 3. So go ahead and move it 1, 2, 3. Now that technique, I need to fix this because that's not a good one. All right, so let's try again. So we had a point here and a point here. Okay. So go ahead and move this second one right 3. And you're going to flip it upside down. So we're going to go down 1, over 1, down 1, over 2, down 4. Over 3, down 9, and do the same thing over here. All right, and now we can connect it. This is really, really bad. Okay, and you can see that they intersect once, and it's just right here. And that ordered pair is going to be 2, -1. Okay, so mine's really not that good because this board's hard to connect a smooth curve with, but sometimes they will intersect one time. So let me kind of show you. When we do a linear quadratic, if I have a line like this and a parabola like this, what would be the answer? Do they ever intersect? It's going to be no solution. Okay, but I could have a linear and a quadratic that hits twice. We would have 2 ordered pairs. We could have a linear and a quadratic that just hits once right here, and that would just be one solution. We could also have 2 quadratics, one like this and one like this, and obviously we would have 2 solutions there. Okay. We could have a quadratic never intersect, so that would be no solution. And we could have a quadratic and a quadratic maybe just hit once, so something like this. And that would just be one solution. Okay, so they can either have 2 solutions, 1 solution, or no solution. And remember that we have linear quadratics and quadratic quadratics. All right.